Okay, so a little bit for the kids at home. We were talking today about the square root of negative 1. And when you try and take the square root of negative 1 on your calculator, crazy things happen. If you do a, hold on, clear. If you do the square root of negative 1, it doesn't work. Non-real. So then what we said is if you do take the square root of negative 1, we're going to call it I. I is a crazy little word, crazy little number, but it's a number. So I is an imaginary number. I represents the square root of negative 1. So whenever you take the square root of negative 1, you write I. I'll say it again. Whenever you take the square root of negative 1, you write I, okay? So then we showed an example down here. When you take the square root of negative 9, get the square root of 9 times the square root of negative 1. That's an I. That's an I. Square root of 9 is 3, okay? Then we did a warm-up where we solved this problem, and then we ended up taking the square root of negative 1, I, right? But two answers, plus or minus I. Then example 2, in our warm-up, we factored, we solved, we took the square root of 9 plus or minus 3, that's okay. But then we got, once again, the square root of negative 1, we got I. So we did get 4 answers, 2 real answers and 2 imaginary, right? And then finally in number 3, it would not factor, so we had to use our quadratic formula. We talked about the quadratic formula. We plugged in A, B, and C, and we worked it out, worked it out, worked it out, worked it out. We got all the way down to here. Uh-oh. We got the square root of a negative number. But we knew that that would be square root of negative 1 gives me an I. Square root of 16 is 4. And we wanted that answer. Okay? So let's take a look at the notes knowing that, right? So starting on notes today, our objective is to finding all zeros. We're going to call them roots today, okay? It's a weird word, we'll just call them roots, okay? Find all zeros, roots. And we use the word roots when we're talking about imaginary and real. So we're going to talk about real and imaginary. Okay? If it's a real number, if it's a real root, if it's real, then it's going to be an x-intercept. We've seen that, right, from yesterday's assignment, right? When we did these, when we graphed them, if it's real, it's going to be simply an x-intercept. If it's imaginary, you won't see it on the graph at all. All right, so let's take a look at example 1. Okay, I have, find all roots, real or imaginary. So let's do what we've been doing. I see 1, 2, 3, 4 terms, right? So I'm going to go and do this one by grouping. Pair these two up. Pair these two up. I'll take out an x squared. And I'll have a x minus 3. The second group doesn't have anything in common, but I want to make it look like this. It has nothing in common, but I want to make it look like this. So I take out a positive 1, okay? I mean, there's really, in a sense, a 1 here. We just don't write it. So if I take out a 1, I'm left with my x minus 3. Now, that's going to help me to finish factoring this because with grouping, I'm always trying to get to this point where I've got the same thing twice. So this is what I have twice. So I'm going to rewrite this as a x minus 3. Take that out. And then I'm left with a x squared plus 1. Aha! Okay, now we can do this. We've seen this problem, this exact problem in our warm-up. So let's just finish this up. Let's get x minus 3 equals 0 and x squared plus 1 equals 0. Go to my mini equations, right? Mr. Sunich, what do you got for me?
A microphone.
Good. You know, this works. If everybody were, this is such a slick deal.
Yeah, and then what you do is just put this like right here, and it goes 25 feet.
I love it. Okay, cool.
So put a help desk ticket so you can make me down.
Right. So when people want to Zoom and teach at the same time, this setup's good. And I'm recording right now, too.
Yeah.
I know.
And then this would just help where your kids
Well, my
online.
my voice gets tired by the end of the day, so.
So your kids online would be able to hear them.
Even better. Cool. Yeah, Mr. Sunich. Okay, back to this. Plus 3 plus 3. Yeah, absolutely. Hey, square root of negative 1. We're going to go imaginary. Minus 1 minus 1. X squared equals negative 1. You guys agree? Are you with me? Square root. And we've done this, right? We know what this is. We've done this. We know the square root of negative 1 is I. Has to be 2 answers, So it's plus or minus I. And I do have 3 answers, don't I? I have 1 real and 2 imaginary, okay? How am I doing? Okay. Good. Now example 2. To do example 2, we may have to graph it. So it won't factor. It won't factor. So this one's going to take some work. So it's not going to factor. So I say look at the graph. So if there is, I know if it's an x cubed, it's got to go. It has to have 1 real root. So I'm going to go into my Desmos. And what we're looking for, whoop, that's Spotify. I don't want Spotify, I want Desmos. Here we go. So let's check this out. Let's see what I got. So I'm going to go y equals x cubed, right? Subtract 3x squared plus x plus 5. Okay, there it is. Oh, must have something going, huh? I don't know what that was. Okay, let me keep going. So now, what I have is I know for sure 1 answer. Let me tap on it. Okay, I know 1 answer is -1. Okay, that's one of my zeros. So right off the bat, I can say x equals -1. Okay? So how to get the other 2? Because the other 2 are going to be imaginary. See why they're imaginary? They don't cross. But I do have 2 more answers. They have to be imaginary because this never comes down. That's how it works. This never comes down and touches, so I have 2 more, and they have to be imaginary because they're up here, right? So how do I get it? So to get the other 2, I'm going to use synthetic division. To reduce this to an x squared equation. To an x squared equation, okay? Right? So I know -1 works. So let's take -1 and let's use synthetic division and see then, once I get it down to an x squared equation, either it'll factor, or we'll have to use a quadratic formula. Okay, so 1, -3, 1, 5. Welcome to Algebra 2, huh? Now we're getting to good problems, huh? This is not geometry anymore. This is good stuff, right, Edie? Yeah. So step 1 is to bring that 1 straight down, right? And then 1 times -1, right, is -1. And we add, and we get -4. -4 times -1 is a 4, and then we add, and we get a 5. And we multiply, and we get a -5. And that's what we wanted. We wanted a remainder of 0. We know that. We know that this is a factor. We already knew it was a factor by the graph, right? So I expected a remainder of 0. Does that make sense? I already knew this was a factor because it was a 0, okay? Now, what do I have? I have a 1x squared minus a 4x plus a 5. So I know there's 2 more, right? So the next 2, let's see, will this factor? I think this will factor, right? Won't this factor into a, no, it won't factor. So if this won't factor, then the next step is to use our quadratic formula, okay? All right, here's my quadratic formula. All right, -b plus minus square root of b squared minus 4ac all over 2a. So I'm going to do that. So I'm going to get this. I know that a is 1, b is -4, and c was 5. And so here we go. I'm going to go quadratic formula. Let's see if I can get this in. Slide that right up in there. So you can see my quadratic formula. -b, so I'm going to go -4 plus minus square root of b squared, which is -4 squared minus 4 times a times c, which is 5, all over 2a, which is 2 times 1, okay? So I'm going to get the other 2 zeros, other 2 roots, by using the quadratic formula, okay? And then if I simplify this, I've got a positive 4 plus minus square root of a 16 minus 20 over 2. I'm going to run out of room, but I can squeeze this over here. I'm going to get, let's see if I can, I might have to squeeze it over here so you guys can see it. 4 plus or minus the square root of negative 4 over 2, right? 6 minus 20. Okay, that's got to be an I, right? That's got to be an I. It's going to be a 2I. You guys okay with 2I? That's going to become a 2I because the square root of 4 is 2, and we got our negative 1, right? So we're going to have 4 plus or minus 2I over 2. And I'm really squishing it in, so I'm going to bring it all the way over here. Sorry, you guys. It's kind of a mess. So my answer is a 2 plus or minus 1I. 2 plus or minus 1I. And there's my answer. Okay? Not that hard. Not really. Okay, return the page. Okay, we're going to do one more, okay? Actually, I got 2 more, okay? Okay. Graph to find a root. Same kind of process, right? I don't think this factors. If we take out a 15, yeah, I don't think it factors. So if we find, let's see if I can graph this one. X cubed, subtract 3x squared minus 15x plus 125, okay? All right, now I'm going to have to take a look at my graph. Got one right here, negative 5, right? Negative 5 is definitely a root, okay? So I know for sure x equals negative 5 is root. So again, how do we find another root? Well, we need to reduce this down. So let's use synthetic division again. Synthetic division. Okay, and I'm going to explain why the synthetic division is important, okay? So write that down. I'm going to flip the page real quick, okay? So, when we took this x cubed and we used synthetic division, it changed it to an x squared, right? You guys agree with that? When we used synthetic division, we reduced it to an x squared, because that's how synthetic division works, okay? Quadratic formula always works, but the quadratic formula only works on x squareds, okay? So that's why we do our synthetic division, because we'll change this from an x cubed, it'll go to an x squared, and so if we get it to an x squared, we can use our quadratic formula, okay? So I'm going to go negative 5 into 1, negative 3, negative 15, 125. I know the reminder's got to be 0. Has to be. The reminder's got to be 0 because I already know it's a factor, right? It's a factor because it crosses the axis, okay? Step 1, bring down the 1. I better get a remainder of 0. If I don't, then I did something wrong, right? 1 and multiply, get a negative 5. Add, and I get a negative 8. Multiply, and I get a 40. Add, and I think I get a 25, right? Multiply, and I get a negative 125. Good. All right, awesome. So what we have then is a 1x squared minus 8x plus 25 equals 0. And again, that won't factor, right? That's not going to factor. So we've got to use our quadratic formula. And I'm going to run out of room, so I may have to do that scooting it over here because this problem's not going to take that long. So here's my quadratic formula. Shift that so everybody can see it. Negative b, there's b. Right? I'm going to put that there and there. So I'm going to go negative b, so I'm going to go negative 8 plus or minus the square root of b squared, or a negative 8 squared minus 4 times a, which is 1, times b, which is 25, all over 2 times a, which is 1. How am I doing, okay? We're definitely in Algebra 2 now, aren't we? We're doing hard problems. Negative negative makes a positive 8 plus minus the square root of 64 minus 100 all over 2. Was that 36? I think it is 36. Negative 8, positive 8 plus minus square root of a negative 36, right? Eight plus or minus 6 I over 2, and you guys hopefully see where I got the I from. The I comes from the square root of negative 1, right? Everybody see where the I comes from? And then finally my answer is going to be, if I reduce, it's going to be a 4 plus or minus 3I. Okay. Amazing. These are good problems, aren't they? Okay, last example. We're going to go backwards. Okay, these are my answers. These are my answers. I want to find the original polynomial. Well, I have the answers. And then the answers came from factoring, okay? Or mini equations, okay? So I have an x equals negative 1/2, right? I have an x equals the square root of 2. But how did I get the square root of 2? How did I get the square root of 2? What kind of problem would have got a square root of 2? Right? Well, it would have had to originally been an x squared equals 2. Does that make sense? I mean, to get a square root of 2, it would have had to been an x squared equals 2 because I squared root squared, right? And I have an x equals 3I. But how did I get that original problem? It would have been probably an x squared equals a negative 9. Because if I take the square root of negative 9, I'd get a 3I, okay? All right, so then I want to make mini equations, so if I multiply up the 2, I'm going to have a 2x equals negative 1. I just multiplied up the 2, because I need to make mini equations. Remember the mini equations? Plus 1 plus 1, 2x plus 1 equals 0, okay? And then this one, if I bring over the 2, the mini equation, if I bring over the 2, I have to subtract 2, would have been a x squared minus 2 equals 0. And then to get a mini equation from this one, I'll bring over the negative 9 by adding it. So bring over the negative 9, I'll add it, and I'll get a x squared plus 9 equals 0, okay? So then my original equation would have looked like this. I'm going to say p of x because it is a polynomial. P of x, it's a polynomial, would have been a 2x plus 1 times an x squared minus 2 times an x squared plus 9. Okay? And we are going to stop with that. I don't need you to multiply it out, because if you multiply it out to make it look more like one of these, you might make a mistake and get the wrong answer. This is the correct answer. It's just in a factored form. Okay? All right. Thumbs up. Okay, so the assignment is really 2 through 7 with number 8 as the extra.